So guys, let's move on to the next question. In the question, it's given that the sum of the integers of list S is equals to the sum of the integers of list T. We don't know how many integers are there, but we know that irrespective of the number of integers, if we do the sum of all these numbers of list S, that is equals to the sum of all the numbers of list T, right? The second thing which we know is that the mean of S, or the mean of all the numbers of the list S, is less than the mean of all the numbers of list T, right? And we have to compare the number of integers in the list S and the number of integers in list T. Okay. So, for example, let's suppose list S, right? S is equals to 2 comma 2 comma 2, right? So the sum becomes 6, 2 plus 2 plus 2. And let's suppose T is equals to 3 plus 3 and 3, 3 comma 3. So the sum over here becomes 6, right? So we were given in the question, the sum is both the same in the list, in list S and list T. So you can see in list S and list T, the sum is the same, right? And we were given the mean of S is less than the mean of T, right? So what is the mean of S? Mean of S is equals to 2 plus 2 plus 2 upon 3, right? So that means 6 upon 3, which is 2, right? And mean of T is equals to 3 plus 3 upon 2, right? The sum upon the total number. So 3 plus 3 upon 2 numbers are there, so 2. So 6 upon 2, 3, right? So this is also valid, that the mean of S, which is 2, is less than the mean of T, which is 3, right? So both of these conditions are satisfied, right? This condition and this condition both are satisfied. So now let's see this. The number of integers in S. How many integers are there? 3, right? In S. And in T, how many integers are there? 2. 2. So 3 is greater than 2, right? So this is the case 1. In this case, the answer is A, right? According to this case, the answer is A. Now let's take another case, right? For example, now let's take S is equals to, now what we are doing is that we want to prove the opposite. We want to prove that the number of integers in T is greater than the number of integers in S. So that means we'll get D as an answer. So sometimes the answer is A, sometimes the answer is B. So we'll get D finally as the answer. So that is how we generally approach the questions, trying to do that. If you are not able to do that, obviously the answer is A. But firstly, we try to do and make a contradiction, right? So now I want to achieve the goal that I want this side to be greater than this, right? The condition being that both of these things should be satisfied, obviously, because these are given in the question. So firstly, the sum should be the same, right? So let's suppose this is, for example, minus 3 comma minus 3. S has two numbers, minus 3 and minus 3, okay? And T has three numbers, minus 2 comma minus 2 comma minus 2, right? Because I wanted to show there are number of integers in T is more, so I took 3 numbers over here and I took 2 numbers over here, right? The condition being the sum of both is same, because the sum is minus 6 and the sum over here is also minus 6, right? What about the mean? The mean will be minus 3 plus minus 3 upon 2. So minus 6 upon 2, which is minus 3, right? The mean over here will be minus 2 plus minus 2 plus minus 2. That means minus 6 upon 3, 3 numbers means minus 2, right? So again, if you see, the mean of S should be less than the mean of T. So over here, the mean of S, which is minus 3, is less than minus 2. So this is satisfied, right? Now we have to see this. The number of integers in S is 2, right? The number of integers in T is 3. So obviously 3 is greater than 2. So according to this, the answer should be B, right? So sometimes the answer is A, sometimes the answer is B. So we can conclude that the final answer will be D. I hope this is clear. So in all these questions, what we try to do is that firstly we come to one conclusion and then we try to achieve the opposite conclusion. If we are able to do that, we get D as the answer. If we cannot find any case, then obviously the answer which was in the first place is the final answer. I hope this is clear.